to the moon to learn how to live on other planets for the benefit of all.
Let's go.
Hello and welcome. We're here at NASA Langley Research Center in Hampton, Virginia. We're about to drop this 14,000-pound Orion crew module into our Hydro Impact Basin. I'm Allie Olney, and I'm here with Debbie Korth, the Orion Crew and Service Module Manager, and Jacob Putman, a data analyst here at Langley. We're here to talk about Orion and everything that's going on with it. We want you all to join us in this conversation by asking questions in the comments below. So make sure to put a hashtag AskNASA. So let's get started. Debbie, can you tell me a little bit about Orion and what we're testing today?
Yeah, sure. Hi, Allie. Hi, Jacob. It's great to be here today and really excited for the test that's going to be starting up behind us and not too long from now. So Artemis is charged with taking the first woman and the next man to the lunar vicinity. And Orion is a big part of making that architecture happen. So Orion is the spacecraft that's designed for deep space. In fact, it's the only spacecraft we have that's specifically capable of bringing crew members back from the vicinity of the moon back to Earth. So a little bit about Orion. Orion is comprised of about three modules, the launch abort system, the service module, and the crew module. So the launch abort system is designed to take the crew module away from the launch site or the rocket in case there's an emergency. Otherwise, it detaches from the spacecraft, and the crew module and service module continue on their journey to space. Once in space, the service module provides all of our propulsion and our power for the entire spacecraft. It also provides what we call services, like our fuels, our oxidizers, all the commodities, our gases, our water. All of that's stored in the service module, and it stays connected to the crew module for most of the duration of the mission. And then the crew module itself is the habitable volume where the crew actually lives. And so it's designed to house 4 crew members for up to 21 days, and it provides everything that they need to live and work in space. So you got environmental control systems, life support systems, all your guidance and navigation and control, your displays, and then the things the crew needs to just actually live. You've got a galley and an exercise device and a bathroom. And on the outside of the crew module, we have thermal protection systems that protect the crew and the vehicle upon reentry at the high temperatures that they see. And finally, a parachute system that deploys and slows that crew module down as it enters the water for its splashdown. So that's basically what we're testing here today. The water impact tests are looking at dropping the crew module in a variety of conditions, looking at how the structure responds to that water landing, which is a pretty significant event for the crew module.
That's awesome. Thank you, Debbie.
Yeah, sure.
So we're standing here at our gantry. Jacob, can you tell us a little bit about this facility?
Sure, Allie. So today we're going to be dropping the Orion test article into the Hydro Impact Basin here at NASA Langley. The Hydro Impact Basin first began construction on it in 2010. The Orion program invested $1.7 million in this facility so that we could ensure future spacecraft are able to return our astronaut crew back to Earth safely in water-based landings. Now, the Hydro Impact Basin measures over 100 feet long, 90 foot wide, and 20 foot deep. And at its completion in 2011, it was filled with 1 million gallons of water. Since the completion of the Hydro Impact Basin, we've tested the Orion spacecraft in a variety of impact conditions, as Debbie mentioned, which has allowed us to ensure that no matter how the vehicle lands in the water, it will do so safely for our crew. In addition to testing Orion, we've also been able to test some of the commercial crew program vehicles out here at the facility, really ensuring that no matter what spacecraft our astronauts are in, they are able to return to Earth safely. One other thing I have to mention about this facility, because it's very interesting and unique about it, is that the Hydro Impact Basin is actually located at the west end of the lander test facility here at Langley, otherwise known as the gantry. The gantry was actually built in the 1950s or 60s for the Apollo program and used as a lunar simulator. So the first astronauts actually learned how to land the lunar module, as well as first learned how to walk on the moon here at this test facility. So super interesting and unique test facility, and really excited to see another historic test be performed here today.
Thanks, Jacob. That is so exciting. And as you said, we have had many Orion tests already happen here. And Debbie, the Orion crew module is already down at Kennedy Space Center, ready for Artemis 1. Can you tell us why we're testing again today?
Yeah, sure. That's a great question. So, yeah, we have done a series of test campaigns at this facility with a series of different modules for the crew module. The article we have here today is called our structural test article, and what makes it different is exactly identical to the actual flight structures that we've delivered to Kennedy, and we're in the process of building up there. So it has all of the flight-like pressure vessel, the back shells, the heat shield structure. Also contains a lot of secondary structure and mass simulators for different components that would be installed inside the crew module. So it's a much higher fidelity model that we'll be using for this test. What it allows us to do is look at how the loads are transmitted into the vehicle and ensure that our load predictions and our margins for the vehicle are sufficient and good for our flight vehicles. So that's the difference with the vehicle we have today.
Wow. And so what's next for Orion?
There is a lot going on Orion right now. It's a very exciting time to be in the program. So for Artemis 1, as you mentioned, our crew and service module have already been delivered at the Kennedy Space Center. They're in the process of getting all of their commodities loaded, so the fuels and oxidizers and all the gases needed for flight. After that, it'll move on to a launch abort facility where we actually installed the last Artemis 1 on top of the crew and service module. And interestingly enough, the actual launch abort system was designed and built and managed out of here at Langley Research Center. So it was the first module that we delivered for Artemis 1, and it's been at the Kennedy Space Center awaiting the crew and service module, which is now ready for integration. So after that, it goes to the vertical assembly building, gets installed on the SLS rocket that'll be showing up later this year, and all headed towards our uncrewed launch by the end of the year. So really excited to see that Artemis 1 vehicle go into a long trip around the moon. Artemis 2 is also well into fabrication, so the crew module is being outfitted with all of its environmental control and life support systems. The prop systems are being welded into that vehicle. The TPS, the thermal protection system, is being installed. So that vehicle is well on its way to coming together. And the parts of the service module we have parts of our service module that actually come from Europe. It's the European service module. It's kind of the guts of our service module, the prop system, and that'll be delivered later this year. All of that follows the very similar path, gets integrated, and similar path as Artemis 1, goes to the rocket, and it's targeted for launch in 2023. And finally, we've already started fabrication and buildup of the Artemis 3 unit. So just really exciting time to be in the program. Lots of vehicles being built, lots of testing being done, and really great.
Absolutely. No, we are so excited for all of this testing and all that is to come for Artemis. So back to our Artemis test today, or our Orion test today. Jacob, can you tell us what we're going to learn from this test today?
Sure. So we actually have over 500 sensors integrated into this test article. We really split those sensors into two categories. We have sensors which are intended to measure the forces that are acting on the test article during the impact event, and we're also measuring the motion of the test article as it moves through the water during the landing. So these are really going to tell us two things. Those forces are going to tell us a lot about any risk to the structure of the test article or any components inside of it, and the motion of the capsule through the water is going to tell us a lot about what the occupants inside might be experiencing. So really, with this test, we're ensuring that both the test vehicle or future Orion vehicle, as well as the occupants inside, are safe during any future landings.
That's so great. And so there's obviously a lot of preparation behind us going on. Can you tell us all that went into getting Orion ready for today?
Sure, yeah. So the test today is going to be really short. Dropping into the water doesn't take a lot of time, but there's a lot of work that goes into preparing this test article before it gets to what you guys are going to see today. So the test article itself was developed, built, and assembled by Lockheed Martin. At its completion, it was shipped out here to NASA Langley, where we integrated all the sensors. We attached them into our data acquisition systems, hooked them onto power, sealed up the capsule, and then prepared it for testing. Actually, prior to this test, we performed a checkout test a couple weeks ago, just to make sure we were getting all the readings that we expected. Everything checked out fine, so we are ready to begin our test today. So looking forward to it.
Yeah, and we're so excited. I think the test is gonna start soon. We might have to take some questions from social media. So I hope you all have been commenting and using the hashtag AskNASA. Let's go to some questions. Debbie?
Sure.
What will be the splashdown velocity of the Orion spacecraft?
In nominal conditions, when we're actually on a mission, I think the nominal speed is about 10 miles per hour, so it's pretty slow. It can get up to around 20-25, and so the parachute system does a really good job as it comes through the atmosphere. There's chutes that deploy a forward bay cover, and then drogue chutes that deploy, and the main chutes deploy. So there's a series of parachute deploys that slow the vehicle down to a very safe landing speed. As far as the test today, I think it's about 16 miles per hour. Yeah, I will have to get back on the exact number, but yeah, it's somewhere in that ballpark. Looking at the specific landing speeds, we actually vary the velocity and vary the angle of impact of the vehicle in the water to try and capture all of the envelope that we need to design towards.
That's amazing. And so, what's the difference between a hydro impact basin and a sloped swimming pool?
Well, the Hydro Impact Basin is flat at the bottom, for one, and it's also much larger. So the volume of water that goes into it, which again, 1 million gallons of water, is needed to ensure that we can test high velocity impacts into the water and basically make sure the capsule is not hitting the edges of the pool. So those are kind of the primary differences there.
And do you know, is the basin saltwater, and how deep is it?
So it is 20 foot deep, and it is not salt water. It's a mix of light bit of chlorine, but mostly just normal tap water with some chlorine in it to make sure it's clear for underwater cameras.
Not made for swimming, though.
No, not made for swimming.
So, Jacob, what is the team looking for to qualify as today's test as a success?
So to qualify the test as a success today, we want a nominal release from the hook. So we want to actually see it drop into the water. After that, as long as it pops out of the water afterwards and we get all the data that we intend to get out of the test, it will be everything we're looking for.
That's great. So Debbie. 2 minutes. Oh, so as you can hear, we're about 2 minutes away from the splashdown test. So I think we'll keep taking some questions from social. So make sure you're still leaving those comments down below and using hashtag AskNASA. So Debbie, when Orion splashes down, how fast will it be going? Or how fast will it be going?
I think the range is about 10 to 20 miles per hour. And like I said, the parachutes do a really good job of slowing down the vehicle on impact. We also have inside the vehicle, to protect the crew, what's called the crew impact attenuation system. So think of like shock absorbers on your car, or maybe like your if you have a mountain bike, something like that. So it actually it softens the impact of the vehicle when it lands. So not only very, very smooth, and not very much dynamics there.
Not getting all jostled around as they're
landing.
No.
They have very nice crew attenuation and nice cushioned seats that help attenuate that load into the crew member. Yep.
Great. And I think we have maybe time for one more question. How long will it sit in the water once it sits down? It hits the water.
The nominal recovery is pretty quick. I think the requirement is it can be there for up to 2 hours, but we actually have recovery crews on site that get to the vehicle almost immediately, extract the crew, get them back on the recovery ship, and then actually tow the vehicle back into the recovery ship for deconfiguration. And actually, starting with Artemis 3, we'll be reusing those crew capsules. So
awesome. Well, thank you. We're going to get to this test.
15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, release.
was amazing.
Yeah, it was really cool. What'd you think?
Yeah,
How's it look?
perfect. Yeah, can't get better than that. It looked like a perfect release, and yeah, it looks like capsule behaved as expected.
That's so great to hear. So I think we are gonna try and take a couple more questions from social, and then maybe possibly see a replay of this drop. Let's see. So we have so many questions from social coming in. Jacob, how high was Orion dropped from today?
So Orion was dropped about 7 feet in the air. So not a whole lot of height, but plenty enough to get some good speed into the water and make a nice splash like we saw today.
Awesome. And Debbie, we've got lots of questions for
Sure.
Debbie.
Sure, what's up?
So what other tests are there? What's this test particularly used for?
Okay, so yeah, this test is very specifically used for our structural verification and qualification. So as I mentioned, it's an exact duplicate of our flight design, and so that's the primary reason for doing all of these different water drop tests, is to make sure that we've predicted our loads accurately and that the margins that we have in the vehicle are actually in the flight vehicle that we have built. So there's a whole lot of other testing that goes into building a spacecraft. So when you talk about the actual flight vehicles with all of the instrumentation and equipment that's installed, we do lots of thermal cycle testing, thermal vacuum testing, vibration testing. Every component that goes in the vehicle goes through its own test program, and then the vehicle as a whole goes through a very elaborate test program where we do a thermal cycle, thermal vacuum, EMI, EMC. So the flight units and the flight vehicles are very well wrung out before we fly to make sure everything will work properly in the very harsh environments of space that it'll be operating in.
Oh, wow. That's amazing. So we've got a couple questions about parachutes. So are there going to be parachutes on Orion, and how many parachutes will there be when it lands?
Okay, when it actually lands, it lands under 3 main parachutes, but it actually can land sufficiently under 2. So it's one of our systems that has a lot of redundancy and safety built into it because it is a safety critical system. There are a series of parachutes that deploy as the crew module enters the atmosphere and to slow it down. And as far as testing, the parachutes have actually completed their entire test program. So there were dozens and dozens of drops of test articles and what we call lawn darts and other items out the back of airplanes, looking at every possible permutation of that parachute system. So you want to make sure if you had only 2 drogues open or only 2 main parachutes open, that you can actually, the crew would be able to survive any kind of anomaly event. And testing all sorts of wind speeds and other parameters you have to test to make sure your parachute system is complete. So ours is actually finished certification. It's installed in the vehicle and ready to go.
That's awesome. So how many drops have been done on Orion? Sorry, wrong question. Is Orion going to carry astronauts to the moon or Mars? And how many crew can it hold?
Okay. Yeah, in fact, that's exactly what Orion is designed to do. It's designed to carry crew members to the lunar vicinity. And right now, the current module will hold 4 crew members for up to 21 days of active use. It's about 200 days of quiescent use. So if the crew left the Orion vehicle and went into, say, like a gateway or a space station orbiting the moon, the vehicle is fine in a quiescent mode for up to 200 days. So, yes, definitely designed exactly what it's designed for, to take crew members to and from the lunar vicinity. Now, to the lunar surface, you're talking about a lander or something else. The Orion vehicle itself does not actually go to the surface of the moon. You'd have a lander that would take your crew members. And I think the architecture for Mars is still being discussed on what kind of transport vehicle you would need. Certainly some additional support services for a mission of that duration.
Very cool. So will there be future Orion tests done at a higher height?
Yeah, there are more tests planned as a part of this sequence. Jacob, you want to talk about the next few tests coming up?
Sure. So we are going to do one more straight drop test at this test facility. We'll lift it up much higher than this test here, really to exercise the capsule as it impacts the water. And then we're also going to be doing a swing test where we'll actually pull the vehicle back towards the east end of the test facility and allow it to swing into the water. So we'll have a combination of both horizontal and vertical velocity. So yeah, I think we have 2 more tests planned for this test article here.
Right, because this is the second of 4
Yes.
for this crew module. And do you know how many sensors are on this Orion test vehicle?
So yeah, we have 500 different sensors on this test vehicle, and they are a combination of strain gauges, accelerometers, and rotational rate sensors distributed throughout the test article.
Wow, that's awesome. And we actually have a special guest with us. Our center director is here, and he actually brought us something to show. If we want to come over here. Hi. Clayton, would you like to explain what this is?
So this poster represents why we're doing all this. It's not only the Artemis program and using the Orion capsule to return to the lunar surface, but it's talking about our future where humans are on Mars. And you notice the caption, first day of school. So we're projecting into an amazing future for all of us.
Fantastic, thank you.
Very cool.
Thank you so much. And that was NASA Langley Center Director, Clayton Turner. So great information. So thank you, Clayton, for coming on. So we have a couple more questions here on social. Debbie, so what other tests are being done for this particular article? What other tests was this particular test article used for?
Okay. Yeah, the STA, the structural test article, has been part of several tests. Like I mentioned, some of the testing that we talked about earlier on all of the environmental testing done, like the thermal vac, thermal cycle, vibration. So we use this test article. This is sort of the end of the road for this test article. This will be its sort of last big test to qualify the structure, but it's been used all along the way for a variety of tests to verify the vehicle design.
Wow, awesome. Well, I think that's a wrap for us today. We thank you guys so much for joining. If you want to know more about the Orion spacecraft, you can follow them on Facebook or Twitter, and as always on nasa.gov.